I'm going to explain how to use the chain rule, but before we get to that, I want to first explain the importance of understanding how to identify composite functions. And the idea behind it is that when you have a function f of x, it can be expressed in the form of f of g of x, or in other words, there is some smaller function within a larger function, or an inside function rather, that can be expressed in terms of an outside function. And the best way to explain this really is to just give you an example. So let's take the example of h of x is equal to x plus 2 squared. Now, if we can break this function down into two components, it is probably intuitive that we would make our f of x, or our outside function, equal to x squared, since whatever term that we see in here can be expressed in terms of another function. This will be our outside function, and g of x will be what is found on the inside. Now, we can see that this works because when we take f of g of x, we still end up with our original function of h of x, or in other words, this is equal to h of x, which is equal to x plus 2 squared. The idea is that we have to be able to identify outside functions and inside functions before we can begin to differentiate these types of functions. Now, let's just go ahead and try to differentiate this. So if we're trying to find h prime of x, then the chain rule tells us first we have to take the derivative of the outside function. Now, in this case, at least for me, it's useful to first identify what the parts are. And now that we know that this function right here is our outside function, and this function right here is our inside function, we can begin to differentiate this appropriately. Now, the chain rule says first take the derivative of the outside. Now, our outside function is equal to 2x, so we're going to bring the 2 to the very front, and then we're going to subtract the exponent by 1 using the power rule. So, in other words, we have 2 times our x value, and because this is technically our outside function, we still have to keep what's inside of the function. We can't change that. So we'll keep the x plus 2, but now we have to remember that the 2 that was originally as an exponent is now going to be reduced to 1 because of the power rule. And now the chain rule tells us to take the derivative and multiply this part by the derivative of the inside function. And the derivative of the inside function is equal to x plus, the derivative of the function x plus 2 is just equal to 1, because the derivative of x to the first power is equal to 1, and the derivative of any constant is just equal to 0. In other words, this would be 1 plus 0 or just 1. So we can put it here just for the sake of clarification, but it's not really necessary. And you don't confuse this exponent with this prime mark that we put to identify that we're taking the derivative. In other words, what we just used was the chain rule, and what we get when we simplify this function is 2x plus 4. We can apply this rule to, any composite function really, and some are complicated, more complicated than others for sure. And I think that the best way to get good at these types of functions, to these types of chain rule problems, is to just keep practicing as many as you can until you really get this idea down of breaking down these functions.